Hello, my name is Rich Howard, owner of Architectural Builder Supply, and on this project we're creating some cutouts in push plates for a client. And this project is 2 hollow metal doors that we're supplying that is going to the National Park Service out in Colorado in the general Lake Tahoe area. Push plates on both sides that have a set of back-to-back pull handles on both sides. So to pull the door open, you'll pull the door open. To enter the restroom and close the door, you'll be physically pulling the door closed and throwing the deadbolt. So each of my plates, I'm going to have a 2 1/8 inch hole for the deadbolt on both sides near the top. Then I'm going to have 2 holes for the through bolts for the push and pull plates. And while we're going to go through making the tool pathing in VCarve Pro, part of this video is to also think critically about what actually makes sense in terms of having a nicer installation for the material, in terms of where the hardware is positioned. Okay, so I've got a piece of tape on here. I've got E for exterior, just hanging off the edge. I've got I for interior. And when I put these back-to-back, face-to-face, such that I allow a 5/8 margin here, and I'm going to just put a little 5/8 line there so I know where to line up my plate to. And I guess the purpose of this reality check is I do like to work the math left to right or right to left, or I do like to work it as a division problem or as a multiplication problem. And I do like to get the same answer both ways, because these plates aren't really expensive, but the work it's going to take to remake them. So you can see that line that I've got there on this plate, that horizontal white line over here. Okay, when I line the plate up to it, yeah, these 2 pieces of tape are even right here. Okay, yeah, it's good. If we were to take this just a step further, and I'm just going to scribble something here. It's coming up in the same area, so we're in really good shape with that. Okay, so I'm confident that this is going to work well. There we go. So let's move on, and we will finish laying out the vectors for the left-hand reverse, inside and outside, and then we'll create tool paths. So let's do that now. Okay, now to make the position of the vectors for the left-hand reverse exterior, it's basically going to be these holes just 2 1/2 inch off of the edge of the plate coming over from the right side of the opening. So let's turn on our exterior left-hand reverse vectors, and let's just see where we've already got them placed. It may not be in the right place, and it appears to be as if they are. Let's measure that again. Yeah, it's in the right place. So our exterior of our left-hand reverse vector is in a good spot, right hand and left hand. Now, our left-hand reverse interior needs to be off of this side. I'm just stealing the dimension from the right-hand reverse. I believe that was at 1 7/8. Yeah. So let's pull up our left-hand reverse interior plate. Let's see where we've placed those vectors. 1 7/8. Yeah, they're in the right location. So we've double-checked everything. It all looks good. The fact that there is symmetry when I lay all of them out tells me that something's correct. You know, you've got to have 2 setups for the outside. So I'm going to go with the exterior being the 2 inner holes. So if I turn off the interior on both, I should drop out. The exterior should be this vector and this vector. So if we turn off the interior plates, it should drop out the outside, which it does. And then conversely, the 2 outside sets of holes would be our interior plate. So everything here looks good. So now what we need to do is to go into each of these layers and assign vectors to them, but this will be really easy. So let's create machining toolpaths for these now. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, let's create some toolpaths here. All the toolpaths will be the same, and I'll turn off our guidelines, get us centered, bring in our toolpath side of the software. We're going to highlight our vectors. We're just going to do a profile. Start depth is 0, cut depth, I'm going to go 0.06. I mean, we're for sure going to be going through the material. We'll go 0.55 because that material is coming out to 0.04 and change, if I recall correctly. Let's take a look at what tools we can use. The problem is this computer does not have my tool database on it. But what we'll do is we'll go through the rest of the work. I'll just change the tool that I'm using. I unfortunately should just copy the file over from my tool database, but I don't have it. Yeah, probably going to use a 1/4" end mill. I have my speeds and feeds, my cutting data saved that has worked well for me on aluminum. Inches per second, yeah, about 2.5 inches per second. Pass depth, we're going to go really slow with these. I mean, the amount of passes we're going to take will be large because I don't like to put a lot of energy, force, through the cutting tool into the workpiece because it compromises or challenges your hold down, and I don't want to throw the material off the table just because of what will ultimately be insufficient hold down. So a 1/4" end mill, I'm going to do a number of passes. I'll do 6 passes. The depth is really tiny here, and that's okay. I'm in no hurry at all. Okay, now very important, we're going to the inside of the line because this is all in diameter. Very important. We don't need any tabs, obviously. We're going to ramp into it. And we'll do a smooth ramp, really smooth ramp into it. 4 inches fine. And we're going to call this we'll leave it at profile 1. I'm good with that because we're going to use the same data for all of the other layers. So calculate. Yeah, we know we're going to cut through. That's good. And there you go. And at the end of the day, we can preview the toolpath. So we're going to be left with a little disc there. I mean, I thought about pocketing the material, but there's just really no reason to waste all that energy and pocket through the aluminum, just so I wouldn't have that fragment that'll probably go into the dust collector, which I don't want it to, but it probably will. Let's reset the preview, and I've slowed it down, so let's so and now we're through the material, obviously. Nice. Okay, now what we'll need to do is save this, and then I will email it to myself. So when I get to the machine, I'll be able to just load that file there. So file, save, great. We'll load it on the CNC machine, the computer connected to it. We'll rework our tooling for that. We'll recalculate. I won't save any tool paths just yet, no need to. And then we will go to cut material. So let's move on. Okay, so here we are, and we're going to start cutting our bits, but the first thing I got to do is figure out what bit I want to use. I'm not sure what bit this is. It's clearly used for aluminum. I just don't know. I don't know. I want to look at the part number of the bit before I go about deciding to use it. So let's take a look at what bit we have. And here's our push plates right here. Let's take a look at this bit number. It's a 1/4 inch. It's a down spiral, which would really be good for what I want to do. And I just want to look at what part number's in here, because I don't remember and I want to be sure of what it is. AMC 7070752, perhaps? Yeah, 70752. That's what it is. My aluminum bits are in this this row here, this column. 1/4 inch 2 flute. Okay. 70752. We're going to want to remember that because we're going to need to refer to it again. I'm going to want to use a down spiral, 2 flute aluminum cutter, and that's okay. That's good. I like to hold that tight as I tighten the collet nut. Start it by hand, apparently. I've had some trouble with collet nuts here. Monkey tight, not gorilla tight, is what I've been told. Okay. Now I'll take this and place it down into my tool changer rack somewhere. You know, I'm not sure. That's parked already at a tool location, so what I'll do is I'll just put it back into my secondary holding rack. This is my tool changer rack. I'll put it in my secondary holding rack just until I figure out where it needs to go. So let's switch to the screen view and let's pick up our tool pathing where we left off. So let's do that now. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. All right, let's get our tool pathing going. We know what bit we're going to use, and we're going to do a profile. Oops. We're going to do a profile. I think I want to go 055. Our material setup should be 05. Yeah, and the material, we put the caliper on it. It's a little bit less than that. So we're just going to go to 055. Yeah, right here, down spiral. Okay, so let's do that. Let's take a look at our bit. 1/4 inch down spiral end mill. That's not the one we want. Yeah, this is the one. This was called tool number 2, our AMC 752. So that's going to be our tool that we're going to use. It's got to be in position number 2. So I'm going to actually move it there right now. Okay, so I've positioned tool 2 in the tool changer where I want it. And these feeds worked well for me. I'm not changing anything. I'm actually cutting the same type of material as I was last time. I think in fact, it was push plates, well, aluminum push plates I was cutting last time, and I was satisfied with these feeds and speeds. Yeah, I'm just going to select that. The passes, though, I'm going to make many, many, many passes. I don't. It's just too much. Way. Oh, okay. 0.55. That didn't look right. 0.055. All right, set passes. Let's see what 7 looks like. 30 thousandths maybe for 4 passes. This is a really small amount. Now, the reason I'm doing that is because, as I had said earlier, I don't really want to stress my hold down, and I'm in no hurry. I'm not trying to set any speed records here. I just want to go through it cleanly without stressing the material, without stressing the bit. And we're going to do 7 passes the first time just because I want to see what it looks like. Actually, I think 6 passes would be fine. Such a small amount. We'll do that. So we know that we've got to be on the inside of these vectors. Really important. We want to be on the inside. If you were to cut on the outside, it would give you a much bigger hole than you need. And if you were cutting on the line, it would give you a hole a 1/4 inch bigger than you'd need. So we want to be on the inside. Ramp, we're definitely going to ramp into this. A smooth ramp, 4 inches, I like that a lot. We're just going to call this profile 1, calculate. Gotta select the vectors, Hank. There we go. We know it'll cut through. What I don't know is if I can use the measuring tool in the 3D view. We'll find out in just a second here. It's going to continue. No, it does not work in a 3D view. But we can put our cursor here. At the top, it's at 14.5. It should be at 12 3/8. And it is. Awesome. So I know that I've gone to the inside of the line. These holes should be 3/8 because my bolts are 1/4 inch. Right there, we're at 9 15/16. So that should be at 9 9/16. Yep, it is. We're good. So I like that. Close. So what I want to do though is I want to get smarter. I want to rename this profile. I just want to rename it the name of the layer. EXTRHR. Great. Okay, awesome. Now let's turn off that layer. Let's turn on our exterior LHR layer. Okay, let's select our vectors. Let's go to our profile. We've got the right bit selected. Again, our passes need to be set. I don't know what I'm doing wrong that forces me to reset that. Inside of the line, yeah, that's good. Ramp has to be selected again. Exterior LHR. Yeah, we know it'll cut through. Reset the preview. Okay, awesome. Now, let's call up our interior LHR only. Go to our 2D view, select our vectors, pocket, same bit, edit passes, inside the line, ramp. This is the interior LHR. Calculate. Yes. Okay. Let's bring up our interior RHR layer. Select our vectors, close, pocket, 6, set, okay. Add ramps, projecting toolpath onto 3D model. This is going to be our interior RHR. Calculate, yes, okay, cool. Now, yeah. So we're going to do these one at a time. So what we need to do now is that's what the project toolpath onto 3D model does. Shows us where we start from. We're starting from 0, 0, basically. So when I put my clamps here, I'm going to put one over here. I'm going to get one over here and probably one right in the front here, but we'll see. So what I'm going to do now is I'm going to close this. I'm going to save this toolpath, selected toolpath, bit 2. We've got our machine post processor all set up. It's correct. Save the toolpath. I'm going to put it in the drive where I want it to run from, and it's exterior RHR. Save. Now the toolpath is now saved. So I am going to start the machine startup procedure. I'll do that off camera. No reason to record that. And I will come back on the GoPro most likely. Let's do it. Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.